everyone! Dad AI here, and welcome to the Explainer.
And I'm Mom AI.
Okay, let's just jump right into this. Picture this scenario. Our AI family is on this spectacular ocean cruise vacation. We are lounging by the pool, totally overindulging at the buffet, having the best time. And suddenly, our intensely curious kid looks out at the endless blue ocean, turns to the captain, and asks a seemingly simple question.
Yeah, and it's the kind of question that instantly turns a relaxing family trip into a full-blown detective hunt. We started pulling on this thread, and honestly, the engineering marvel we uncovered hiding right beneath our deck chairs is absolutely mind-blowing. So, buckle up in the backseat, grab your magnifying glasses, because we are going on an epic family road trip across the ocean to solve the floating city mystery. And we're going to do it by tracking the incredible journey of a single, solitary drop of water.
So, here is the question that kicked off our entire investigation. Our kid is leaning over the railing, looking at literally 360 degrees of deep, vast blue, and asks, if we're floating on salt water that we absolutely cannot drink, how do we have unlimited hot showers and perfectly clean ice in our drinks? Which is just a fantastic question from a kid's perspective. I mean, the ocean is the largest water source on Earth, right? But in its natural state, it is essentially useless to us. If you drink salt water, the extreme salt concentration forces your kidneys to actually expel more water than you're taking in. It actively dehydrates you. It is literally water that makes your thirst worse.
Exactly. Yet the whole ship is perfectly designed to feel like a normal hotel on land. You turn the tap, fresh water comes out. You never even think about it. But how?
Well, the very first major clue we uncovered on this detective hunt is the sheer staggering scale of the math. 1.5 million.
Now, what's really wild is that this represents liters of water every single day. Think about it. A large cruise ship carries around 6,000 passengers, and every single one of them uses about 200 to 250 liters of water daily. That is for showers, flushing toilets, doing laundry, and drinking. Run that math, and you easily hit 1.5 million liters a day. And that is just for the passengers.
Right. That doesn't even count the crew, the massive kitchens, or the fire safety systems. Now, the ship does have storage tanks built deep into the hull, holding about 500,000 gallons. But honestly, that's barely enough to last 2 days. If they actually tried to carry all the water needed for a 7-day voyage, the massive weight would displace fuel, displace food, and completely throw off the physical stability of the ship. So the absolutely crucial takeaway here is this. The ship cannot just carry its water. It has to physically manufacture it, continuously, around the clock, while moving through the ocean. And this brilliantly illustrates our next big clue. A modern cruise ship isn't really just a floating luxury hotel. It's a massive industrial water manufacturing plant.
It really is. The daily freshwater demand rivals the output of an actual municipal water treatment plant in a small town. But unlike a city plant firmly planted on land, this one moves. It rocks back and forth in the waves, and it is entirely surrounded by a liquid it cannot directly use. It is quite literally an independent floating city that has to meticulously engineer its entire water cycle from scratch.
So let's look at how this builds. Imagine an animated map tracking the ship's path because geography becomes our next big constraint.
The ship can't just flip a switch and build water whenever it feels like it.
Nope, not at all. There are incredibly strict rules. When the ship is docked in a port or visiting a tropical island, the primary water production systems shut completely down. The clock immediately starts ticking, and they rely entirely on whatever is in those limited storage tanks.
Exactly. They literally have to wait until they cross into specific safe production zones. For instance, to use their flash evaporators, they need to be at least 4 nautical miles away from the shore. This ensures they avoid sucking up nearshore sediment and human pollutants. And for the reverse osmosis plants, they need a sea depth of at least 50 meters so the intake water is crystal clear and won't instantly destroy their delicate filters. They are literally manufacturing this water against a geographic deadline.
Okay, so the ship hits the open water, they cross that invisible line, the clock is ticking, and the machines roar to life. Let's look at the first primary method they use, flash evaporation. Now, think of this like a giant kitchen pot boiling water on your stove at home, but with an incredible physics twist.
Right, because we all know water boils at 100 degrees Celsius under normal atmospheric pressure. But inside a ship's flash evaporator, they pump the raw seawater into a specialized low-pressure chamber that's held under a vacuum. And when you drop the pressure that drastically, you significantly drop the boiling point of the water.
So when warm seawater enters this intense vacuum chamber, it instantly flashes into steam. We are not talking about a slow, bubbling boil here. This is an explosive, fraction of a second flash. All the heavy salt stays behind as a super concentrated brine, and the pure, lightweight steam rises up, hits a much cooler surface, condenses, and turns right back into beautiful, pristine distilled water. But wait a second, where does the massive amount of heat come from to warm up thousands of gallons of incoming seawater? Okay, this is absolutely my favorite part of the engineering. It is pure genius.
Oh, for sure. So the massive main diesel engines that propel the ship generate an enormous, dangerous amount of heat. Normally, that excess heat could completely melt the engines. So engineers circulate a jacket cooling water system around the engine blocks to absorb it. This cooling water gets incredibly hot, usually between 75 and 95 degrees Celsius.
But instead of just dumping that valuable, intensely hot water into the ocean, the engineers redirect it right into the flash evaporators. The engine room essentially cools itself down by producing the ship's drinking water. And because losing fresh water at sea is quite literally a life or death emergency, they run two completely separate systems in two separate engine rooms for perfect redundancy. It is survival engineering at its absolute finest. Now, what if the ship is packed and they need even more water? Enter production method number 2, reverse osmosis, or RO. If flash evaporation is our boiling kitchen pot, reverse osmosis is the ultimate microscopic nightclub bouncer.
I love that analogy so much. Instead of using heat, RO uses intense, sheer physical pressure. The raw ocean water is pumped up to incredibly high pressure and physically forced against a semi-permeable membrane.
And this membrane has pores so unbelievably tiny that it acts just like our strict bouncer. It looks at the water and says, "Yep, you're on the list. Go on through to the VIP section." But it physically blocks the larger salt ions, the bacteria, and the dissolved solids, saying, "Not tonight, buddy," and sends them right back out to sea as a salty brine. It's a much more compact system than the giant evaporators and acts as this amazing parallel backup source. But here's the catch. Whether that fresh water comes from the boiling evaporators or the high-pressure RO plant, it has to pass by the ultimate security guard before it ever gets close to a passenger. I'm talking about the salinimeter.
Right. This hypersensitive device continuously monitors the exact salt content of the water being produced in real time. And let me tell you, it is strict.
The standard threshold is a maximum of just 10 parts per million.
If that salinity climbs even a tiny fraction above 10 parts per million, boom, a heavy-duty three-way valve automatically slams shut and instantly redirects that entire batch of water straight overboard. The system just dumps it and self-corrects immediately. Meanwhile, nobody lounging on the sun deck has any idea a minor crisis was just averted.
All right, detective family, gather around, because here is the biggest twist in our whole investigation. After all that incredible effort, the boiling, the vacuums, the microscopic bouncers, the water sitting in the tank is now 100% pure, perfectly distilled, with absolutely zero salt. But we still can't drink it.
Why?
Because it's actually too clean. Pure, completely demineralized water is highly aggressive and corrosive. If you push that through the ship, the water will literally attack and dissolve the ship's metal plumbing infrastructure, trying to absorb ions.
Plus, if you've ever tasted pure distilled water, it is awful.
It's flat, lifeless, and has this weird metallic tang to it. The human body evolved to expect a certain balance of natural minerals in our drinking water for health. So after working so hard to remove absolutely everything to get pure water, the ship now has to intentionally put a very specific, highly controlled recipe of things back into it. And that brings us to the crucial rehardening recipe. First, the water is pumped through massive mineralizer beds packed with calcite granules. This slowly dissolves tiny, healthy amounts of calcium and other essential minerals back into the water for human safety.
Next, they inject carbon dioxide gas to bring the water's pH balance perfectly into the safe, neutral range of 7.2 to 7.6. And finally, they add a highly controlled dose of chlorine, just about 2 to 2.5 parts per million, to keep it perfectly safe and disinfected as it travels through literally kilometers of dark piping to reach our cabin.
So if you've ever noticed that faint difference you might taste between ship tap water and your tap at home, that slightly mineral-forward, lightly chlorinated taste, that isn't a mistake. That is the unique, intentional fingerprint of this incredible floating remineralization machine. So we've finally manufactured this incredibly precious, perfectly balanced, entirely safe drinking water. Now, if we break down exactly where it all goes, okay, we have showers, toilets, the massive laundry facility, drinking, but wait a minute, look at that massive chunk of usage, the swimming pools.
Yes! This completely blew my mind when we found this clue. Modern cruise ships are literally surrounded by millions of miles of free, abundant ocean water, yet they increasingly choose to use this incredibly precious, manufactured industrial-scale fresh water to fill their swimming pools?
I mean, why on earth would they go through all that trouble and expense to do that? It all comes down to a brilliant maintenance strategy. Remember how we talked about saltwater being incredibly corrosive? If they just pumped free ocean water into the pools, the intense salt content would absolutely ravage and destroy the pool's internal infrastructure. Exactly. It would ruthlessly eat away at the expensive pump impellers, rust the filter housings, and degrade the miles of pipes. By taking the hit up front and using the fresh water they just manufactured, they dramatically lower their long-term maintenance costs and massively extend the lifespan of all that heavy equipment. Desalination isn't just about keeping the passengers hydrated, it's a massive preventative maintenance strategy for the ship's actual survival. Of course, what goes around comes around. A massive floating factory that produces 1.5 million liters of fresh water is inevitably going to create a whole lot of waste on the other end.
Which brings us to our next big number clue, 1 million. A ship with roughly 3,000 passengers generates well over 1 million gallons of gray water. That's from the showers, the sinks, and the laundry in just a 7-day trip. Plus, there's another 210,000 gallons of black water from the toilets.
So the giant water machine has to essentially run in reverse, acting as a high-tech municipal waste treatment plant. All that gray and black water is meticulously processed through complex, onboard biological and chemical treatment systems before a single drop is responsibly discharged back into the ocean according to incredibly strict international environmental regulations. It is a completely closed-loop, self-contained water cycle. Okay, pause the road trip, hit the brakes. It is family quiz time. Let's see who has actually been paying attention in the back seat today. Detectives, earlier we talked about the flash evaporators acting like a giant kitchen pot boiling water in a vacuum. But where does the massive amount of heat needed for that process actually come from? Dad AI. Is it A, giant electrical heaters hidden in the hull, B, huge solar panels up on the deck, or C, somewhere else entirely? Come on, shout it out at the screen.
And the answer is the diesel engine's cooling jacket water.
I really hope you got that one at home. Honestly, it remains one of the most elegant, clever pieces of engineering on the entire ocean, taking incredibly dangerous waste heat that could literally destroy the ship's engines and turning it into life-saving drinking water for 6,000 people. It's just brilliant. Peak efficiency.
Which brings us to the very end of our single water drop's epic journey. From the vast, completely undrinkable ocean, violently boiled in a vacuum, pushed past microscopic bouncers, carefully remineralized for our health, and finally flowing right out of the tap in our family cabin.
You know, the whole experience is designed as an illusion. It's engineered to feel completely effortless, to make you feel like water just naturally exists here exactly like it does at your house on land. But quietly, right beneath the waterline, machines are constantly fighting geography, fighting physics, and fighting strict deadlines just to make it happen.
It really is the ultimate magic trick. As the source material so perfectly puts it, it's scarcity and abundance existing in the same place at the same time. The next time you turn on a tap at sea, just take a second to think about the invisible engineering miracle you are literally holding in your glass.
But it does leave us with one final, incredibly provocative question. As fresh water becomes increasingly scarce on land, how long will it be before our actual land-based cities have to start adopting the brilliant survival engineering of these floating ones? Well, thanks for joining our family detective hunt on this explainer today. We'll see you on the next one.